Hello student. In this video, I will be discussing about the case 4 uh, where F is actually 40 ton and it's a it's a continuation of the three sliding block problem. And as we discussed earlier, basically in my earlier videos, we have taken different values of F when F is the force which is applied on block B in the arrangement which you are seeing right now, and the various values of the static and kinetic frictional coefficients are given in the diagram, and the three blocks are A, B and C with their masses 1 kg, 2 kg and 3 kg. And our task is to find out the acceleration of the three blocks when F is 40 newtons. In my earlier videos, we have done F equal to 5 Newton, F equal to I think 25 Newton, and this here it is F equal to 40 Newton, and see how it changes the various aspects. So to start with, we have to now look at first. We have to understand that this 40 Newton force will try to first break the maximum frictional resistance which is getting offered for the movement between block B and C. So we need to find out what is the maximum frictional force which this force need to overcome. So obviously, why not the other ones? Because for this we need to understand what is the uh, horizontal direction force which starts acting on the block C. Right now, this force is acting on block B only. So, in further in our calculations, we'll do that calculations to understand how the block C is getting impacted. But right now, we are sure that block B is getting impacted. Block A and C, we will see in due course how they are getting impacted. So to start with, what is the maximum frictional force which is between B and C? For that, we should know, we should consider block A and B together, because this block A and B together are exerting the vertical force on the normal force on block C, which is going to be the sorry 30 Newton, because 2 plus 1 third 3 kg mass into we are assuming 10 gram per centimeter square as the value of G, so it is around 30 Newton. So because of this 30 Newton, when we multiply the static kind of force, which is static coefficient, which is zero point 0.3, sorry, zero point 0.4 between block B and C, it is 0.4. So when you multiply that, you will get 3 into 10 into zero point 0.4, which is 12 Newton. So 12 Newton is the maximum value of the frictional force. The moment your force goes beyond 12 Newton, the block B will start sliding on block C. So which is the case here, because 40 Newton exceeds 12 Newton, we will clearly have a sliding motion happening between B and C. But the moment the sliding motion starts, our frictional force will get readjusted to kinetic frictional coefficient into the normal force, which is going to be 9 Newton. So if I draw the free body diagram of block A and B together, because right now block A is directly sitting on block B, and we don't know whether right now they will be moving together. So we have to consider that they are together right now at this moment. So if I put this FBD for A and B together, you can see it here, 40 Newton here, 9 Newton opposing frictional force, and this entire 3 kg into the acceleration of block A and B. If they are moving together, we are right now assuming that at this moment they are moving together. So if you do the calculations, you can do the math, you can see 40 minus 9, 31. 31 divided by 3, that is around 10.33, will be the momentary acceleration both block A and B will experience because of this 40 Newton force. The moment this this acceleration starts, block A will experience a force. Acceleration will instantly create a force on block A, which may overcome, we will have to check, the maximum frictional force between block A and B. So now let us put attention on block A and B, what is happening between the two. So the maximum force will be the normal force, which is 10 Newton, into the zero point 0.5, which is the static coefficient of friction. So it is going to be 5 Newton. So 5 Newton is the force which will be uh, working there, static. And because this 10.33 is greater than 5 Newton, obviously there will be a movement between block A and block B, and block A will slide on block B. The moment block A, so everything is happening in that moment. So the moment block A starts sliding, the frictional force will get adjusted to the kinetic friction, which is zero point 0.4 into 10 Newton, right? So the moment that happens, you will see, let us put the free body diagram, because now block A is freely moving on block B, and the maximum frictional force now, or the kinetic frictional force, will be zero point 0.4 into 10, 4 Newton. And you will see this FBD, and the maximum acceleration which block 1 or block A with 1 kg mass will experience is equal to 4 meter per second square. Because the moment this block starts sliding, only 4 Newton is the force which is acting on this block. And because it has to balance, there will be an acceleration of, in this direction it has to accelerate, because it has to keep on moving, right? And but it will not get the additional force, because the only 4 Newton will get transferred to this. See, so the initial moment is 10, but later on it will become, because the moment it slides, they are not moving together, so it will not take the acceleration of 10.33. It will become 4 meter per second square. The moment this happens, this 4 Newton will have equal and opposite force opposing acting on the below block. So if we have to redraw the free body diagram of block B. So now the free body diagram, and everything is happening in that moment, please understand. So 4 Newton is now acting here additionally, because of the frictional movement between block A and block B. So the FBD will now get changed like this. So this is 9 Newton, which is between B and A, 4 Newton, which is between A and B. Both will be acting, but they are acting in opposite direction, right? So you will have to do the math, and you will understand that it is 40 plus 4, which are in one direction, and minus 9, so 35. So actually the block B will now move with 17.5 meter per second square acceleration. Now the moment this 9 Newton frictional force will start acting on block B, equal and opposite 9 Newton will be acting on block C. But whether that 9 Newton will be able to move block C will be determined by the maximum frictional force between block C and the surface, which will be 60 Newton, which is the working vertical normal force, and static is zero point 0.3. So you will have to look at this here, block C, right? So 18 Newton will be the maximum frictional force, right? So this block 9 will not, the 9 Newton will not be able to overcome this 14 Newton, and hence block C cannot move under that force of 40 Newton getting applied on block B. So one thing is very sure is that this 9 Newton will be the maximum force which block C will experience because of whatever is happening on its top, right? Whatever is happening on its top, the maximum force experienced by block C will be 9 Newton. So even if I change this force to infinite force, even in that case, so that can be variation, you can put infinity there even, and they can ask what is the frictional the acceleration of block C. So you should be very sure that the block C will not move because the maximum frictional force which gets transmitted to block C is not exceeding the frictional force which is holding block C, maximum frictional force. There is a interesting variation I want to put in this particular problem in my next case. uh, that will be, suppose if I put a lubrication. Let us see what will happen, and I will be solving that in my case 5 in the next case, and in my next video. But meanwhile you can try this, you can try to see whether the is there the various things will change between the accelerations. Try it out. Thank you.